On Monday, Daniel had 90 cups, each of which was either purple or yellow. He distributed the cups among 3 boxes as follows. Box D, 9 purple, 23 yellow. Box E, 6 purple, 24 yellow. And box F, 28 cups. What percentage of the cups in box E were purple? All right, so there's 90 in total, and they are either purple or yellow. And they actually help us out a little bit with this information. So we have 9 purple and 23 yellow. And then we have 6 purple and 24 yellow. And then we have 12 purple and 16 yellow. Okay, so I guess I would just have to add up all the purple ones. So that's going to be just the ones in box E. So I guess that's pretty straightforward. So that's just 6, and then the total is 30. So that's all this is really, is just 20%. Okay, B. This says that of the 90 cups that Daniel had on Monday, 30% were purple. How many of the cups in F were purple? All right. So first thing is that of the 90, 30% are purple. So 90 times 30%, so 0.3, that is 27. So there's 27 purple. And then we have to figure out how many in F are purple. So of the 27, we have to get rid of this 9 and this 6. So minus 9 and minus 6. And when you do, and that's 12. And I think that's how I got this 12. Some of you might be wondering, how did he get that 12? Because I'd already done this question, that's why. See, on Tuesday, Avril brought 9 more paper cups and included them with Daniel's cups. Barry brought some yellow cups and included them with Daniel's cups and Avril's cups. The percentage of cups that were purple was again 30%. How many cups did Barry bring? Okay, so you have 90, 27P, 63 yellow, right? So we figured that out. The previous question kind of helped us out. So what do we have to do here? So now they're adding a bunch of cups to this story here. So before we had 27 of the purple, right? But now they were adding 9. So we have 36 purple in total because Avril brought 9. And then with the yellow, before we had 63. And then we're adding some that Barry brought, but we are not told how many, so I'm just going to call it X. And now they're saying that the percentage of purple is again 30. So that means that this 30% is the percentage of purple, which is 36 over the total, which in this case is 36 plus 63 plus X. And I believe that would be the correct formula. Yeah. Okay, so let's do this. So this is 0.3, that's 36, and that's 99 plus X. And 0.3 times 99 is 29.7 plus 0.3. X is 36. And therefore 0.3x is 6.3. And then solving for x, we get x equal 21. So that means that Barry brought 21 yellow cups. The breakfast restaurant has special pricing day, if the customer arrives at the restaurant between 4:30 and 7. The time that they arrive in hours and minutes becomes the price that they pay in dollars and cents. For example, if a customer arrives at 5:23, he will pay $5.23. Abdi arrived at 5:02 and Cayley arrived at 5:10. In total, how much did they pay? Well, one paid $5.02. The other paid $5.10. And when you add those two, it's $10.12. B. Robert arrived 10 minutes before Emily, and both arrived during the period of the special pricing. In total, they paid $12.34. What were their arrival times? So one arrival time I'll call X, and one arrival time, because it's 10 minutes before the the price basically will be x minus 0.1, because each minute refers to a cent. So 10 minutes would be 10 cents, which is 0.1. And they're saying that when you add those two, it's 1234. And that is basically the equation. So that's going to be 2x is 1244. And therefore x is 622. So one of these is 622, and the other one would be 612. So who arrives first here? Robert arrived 10 minutes before Emily. So Robert, I guess, is 612, and then Emily is 622. Isaac and Jacob arrived together, and Carla arrived after that. All three arrived during the period of the special pricing. In total, they paid $18.55. What was the minimum amount that Carla could have paid? Okay, so let's experiment with this. $18.55, right? So we've got three people here. We have Isaac, Jacob, and Carla. And these two arrived together. Okay, so they're going to have the same time. So X and X, let's say. And then Carla arrived after, so she's going to have some time Y. And then Y is greater than X because Carla arrives afterwards. And the total, which would be 2X plus Y, is $18.55. Okay, so we have to just experiment with this. And the key is the minimum amount. So we want Y to be, we want to minimize Y basically. Minimize Y. Okay, so if we want to minimize Y, let's see what we can get. First thing I'll do is just divide 1855 by 3, and just to get kind of a ballpark estimate as to where, and this is about 6.183. So if all three of these were 6.183, then it would total 1855, but we know that all three are not the same. Two of them are the same, though. So what if I make two of them 618? And then in order to get a total of 1855, that would mean the third time would have to be 619. Yeah. And then if you add these up, it's 1855, like in terms of dollars and cents. So that means this is the minimum for Carla. So that's all that is. You just have to play around a little bit. Larry and Mio arrived separately during the period of special pricing. In total, they paid $11.98. Determine the ranges of times during which Larry could have arrived. All right. Well, in total, so the special pricing started at 4:30, right? And I think it ends at 7. So let's experiment with this. Let's see what kind of numbers I get. Let's start with 4:30 as being a price. So if 4:30 is one of the prices, then actually it's a price. So I'm writing it as a time. I should write it as a price. Then the other time will be 7:68. Now 7:68 could be a price, but it can't be a time, right? So that's kind of out. Let's try the other extreme, which is 7 a.m., which is when the pricing ends, and that's 4.98. Now 4.98 could be a price, but it can't be a time, right? Okay. So what do I do here? How about 5 o'clock? Let's see what happens with 5 o'clock. That would be $5 even. That is 6.98. 6.98 can't be a time. So the only way that can be a time is if it gets down to 6.59, right? So let's see what happens if I can. I'm just experimenting. 6.59, 11.98. So this guy in here would have to be 5.39. Yeah. So 5.39 is probably where it for one of them at least, sort of it begins. Yeah. And then now let's try the other end of the spectrum. What happens? Let's try 6 o'clock. So that'd be $6. That's 5.98. Okay, that cannot be a time. But how about we try? How about 5.50? 5.59. Yeah. 1 minute before, and that gives me 6:39. That can be a time. Okay, that works. Okay, so if this is Larry, this is Mio. So we got a little bit of a range here. Larry could be 5:39 to 6:59, right? Yeah, because 6:59 is the first kind of price that, or the last price that kind of could also be a time. And for Mio, it looks like we had 5:59, and then it kind of went up to 6:39. Sorry, 5:59 and 6:39. Yeah. So there you go. You just have to experiment a little bit and come up with these values. Circle is a line or line segment that touches the circle in exactly one place. And that's a tangent, and would not touch the circle again, even if they extended infinitely in both directions. When a tangent to a circle with center O touches the circle at P, the radius OP is perpendicular to the tangent. All right, so in the diagram, O is the center, radius is 18, QR is the tangent, line segment OQ intersects at S, determine SQ. So to me, this is a basic Pythagorean. From O to S is also 18, and then from S to Q, we'll just call it X. So this looks like 18 squared plus 24 squared is 18 plus X squared, like that. And when you do this math, you will basically get X equal to 12. So I'll let you do that. It's fairly straightforward. Part B. A circle is said to be inscribed in a quadrilateral if each side of the quadrilateral is tangent to the circle. A circle with center O is inscribed in quadrilateral ABCD, touching AB at E, BC at F, CD at G, and DA at H, as shown. If the radius of the circle is 12, OB is 15, OC is 20, and BAD and ADC angles are 90, what is the perimeter of quadrilateral ABCD? Well, some of these we can get immediately. The radius has a circle. The radius of the circle is 12, so that means this is 12 right here. And if that is 12, then that's 12, that's 12, that's 12, and that's 12. Okay, so that's so far so good. And then what I'm going to do is I'm going to draw two lines here. One from the center to C, and one from the center to B, like that. And what that does is it helps me because this is a tangent, so that's a right angle. This is a tangent, and that's a right angle. And this is a tangent, so this is a right angle, and so is that. So now we have a few more Pythagorean relationships here. And let's see here. This is 12, this G to O. This is 12, this O to E. And this is 12, this O to F, like that. And then did they give us anything else? OB is 15. Okay, so that's very helpful. So then I can easily calculate EB. Okay, so EB squared plus 12 squared is 15 squared. And therefore EB is equal to 9. You can figure that out pretty quickly. So there's 9 and there's 9. And then similarly, OC they gave me as 20, so that helps. That again it makes me allows me to figure out GC pretty quickly. That GC squared plus 12 squared is going to be 20 squared. And when you figure that out, it's going to give you a value of 16. So that's 16 there, and that's 16 there. You can do the same thing on that triangle. So there you go. You got it all. And when I add it all up, 12, 12, 12, 12, 9, 9, 16, 16, the total perimeter is 98. And finally, circles with centers O and C are inscribed in squares as shown. The area of the larger square is 289. The area of the smallest square is 49. TUV lie on a straight line, determine OC. So the larger square has an area of 289. So if X was one of the sides, x squared would be 289. That means x is the square root of 289. And therefore, that means x is 17. So this side is 17, this side is 17, like that. For the smaller square, if y was the side, y squared would be 49, and therefore y would be 7. So this side is 7, this side is 7, and so on, right? Okay. So now we have to carefully figure out what to do next. I'm going to draw a couple lines. I'm going to draw one line from O to the bottom like that. Then one more line from C to the edge like that. And I think that should be good enough. Maybe one more. One more line from C to the bottom. Yeah, I think that's sufficient. Okay, so here we go. Let's just draw in our little right angles. Okay, so now let's carefully label this. Carefully. The side length is 7, right? Now what I'm going to do, in order to avoid making the diagram messy, I'm going to just draw that a little bit here. So that shape, I'm going to just draw it here. Otherwise it's going to get a little messy. Okay, so exactly what's up there, the OC stuff, I drew it over here. This is O, this is C, and all that. Okay, so, and what else? I got to do a little bit of a line here, right? Okay, so here we go. So from here to here, let me use a different color. From there to there is actually 7 over 2, right? Because it's half. From here to here is 17 over 2. And then from here to here is also 7 over 2, these guys. And therefore, here to here is basically 17 over 2 minus 7 over 2, which is 10 over 2, which is 5. Yeah. All right, I think I have enough. So I'm just trying to figure out OC, right? So using Pythagoras, OC squared would be, this is a right angle, so this squared, which is 5 squared, plus this squared, which is 17 plus 7 over 2. 17 over 2 plus 7 over 2, so that's 24 over 2, which is 12. So 12 squared. Okay, well, that's pretty easy. So OC squared is 25 plus 144, which is 169, and therefore OC is 13. And there you go. A polar rectangle is an m by n rectangle where m and n are integers and m is greater than or equal to 3 and n is also greater than or equal to 3. Has lines drawn parallel to its sides to divide it into 1 by 1 squares. And it has the 1 by 1 squares along its sides unshaded and the 1 by 1 squares that do not touch its sides shaded. An example of a polar rectangle with m equals 8 and n equals 6 is shown. For a given polar rectangle, let R be the ratio of the shaded area to the unshaded area. Determine the value of R for a polar rectangle with m equals 14 and n equals 10. All right. So let's do this here. So we have this scenario. So this is not going to be a work of art, but that's okay. So what is R? They're saying that R is the ratio of the shaded area to the unshaded area. Okay, that shouldn't be a problem. Now, they're telling me that in this case, my m is 14 and my n is 10. Okay, now each of these guys is 1. So that means this from here to here would be 14 minus the 1 there and minus the 1 there. So it would actually be 12. And this from here to here would be 10 minus the 1 there minus the 1 there. So it would be 10 minus 2, which is 8. So in this example, since we have numbers, it's fairly straightforward. The shaded area is 12 times 8. And the unshaded area is 14 times 10 minus 12 times 8. And if we do this math, this becomes 96 over 140 minus 96. And that's 96 over 44. And in terms of ratio, it's 24 over 11. So there you go. Determine all possible positive integer values for u for which there exists a polar rectangle with n equals 4 and r equals u over 77. So what I'm going to do is the same sort of story as before, is if we think about it just from the previous example, right? Just how I did it up here. I'm going to do the same thing. But this time, instead of numbers, we've got some letters here. So the shaded area over the unshaded area is, if we have, let's say, a rectangle like this, and then we have the inside, this is m, this is n, this is m minus 2, and this part is n minus 2, n minus 2. So the shaded area over the unshaded area basically is m minus 2 times n minus 2 all over mn minus m minus 2 times n minus 2. So it's the same story. The only difference is that we have letters this time. And they told me that this ratio, which is called r, is u over 77. And they also gave me that n is 4, so that really helps. So that means I can plug that into here. And when I do, I get 2m minus 2, and then we get 4m minus 2 times m minus 2 is equal to u over 77. Got it? Okay, so we have that, and I guess we have to simplify this now. So if I expand all this, it becomes 2m minus 4, and this becomes 4m minus 2m plus 4, and that's still u over 77. That doesn't change. And then let's see here, this becomes 2m minus 4, and this is 2m plus 4, u over 77. I think we can divide top and bottom by 2 here, and that will give me m minus 2 over m plus 2. Okay, that's a pretty nice result. So what exactly are they asking here? Determine all values of u. Okay. All right. So I got to figure out all the possible values of u so that this is valid. All right. So how do I do that? Oh boy. I think I think I'm gonna have to manipulate this in order to make it workable. So let's see what I can do. This m minus 2. Let's see here. What I'll do is I'll write m plus 2 minus 4. And that's the same as m minus 2, but maybe it'll help. And then that will basically mean it's m plus 2 over m plus 2 minus 4 over m plus 2, like that. Got it? Okay, what this does is it makes this 1 minus 4 over m plus 2. And then this is still u over 77. And then I can bring this over here, 4 over m plus 2, like that. And this is 1 minus u over 77. And then can I do anything? I can get a common denominator and just make the 77 minus u over 77. And this is 4 over m plus 2. And then now I can cross multiply. So it'll be 4 times 77 is m plus 2 times 77 minus u. Okay, I got it. And then this here, I will break it up into prime factorization like that. And I think that is going to be something that will help me figure out what are the possible values of u. Okay, so let's see what we got. So this is a pretty good result that basically just manipulated that. Now you guys remember you can figure out how many factors, actually, not prime, but how many factors there are by working with the exponent. So you take the exponent, add 1, then you take the exponent in the next prime number, add 1, then you take the exponent in the next prime number, add 1, and this is 3 times 2 times 2, which is 12. So there's going to be 12 factors to this number. And those 12 factors are, let me think about this for a second. Well, let's make a list here. 1, 2, 4, 7, 11, 14, 22, 28, 44, 77, 154, and 308. Those are the 12 factors of this number here. And that means that those are the 12 possible values for m plus 2. Okay, so let's make a table here. Let's make a table. And let's see what we get. So we got m plus 2. And then 77 minus u. And then u. And then let's see how many values we get. Okay, so... well, some of you might have already forgotten, but I actually remember that m has there's a parameter. Do you guys even remember or no? Well, let's go back to the question. Let's see if I can... m... The question, for some reason, became all blurry, but m has to be greater than or equal to 3. So that means... so since the parameter is m has to be greater than 3, some of these are immediately going to be eliminated. So if m plus 2 is 1, that means that that's not going to work, because that means m would be 2, here m would be 0, and here m would be, what, negative 1, I think? Yeah, so these two are invalid. These, well, sorry, actually, this is, m plus 2 is actually this guy right here. This is m plus 2. And then this would be m, and then we can put 77 minus u and u. So if m plus 2 is 1, that means m is negative 1, this is 0, and this is 2. So these three values are invalid because m has to be greater than or equal to 3. Okay, no problem. Just keep going here. Let's keep going with these values. So this is going to be, let's say here, 5, 9, 12, 20, 26, 42, 75, 152, and 306. Correct? So then we just have to figure out what is 77 minus u. Now, for the first one, remember we're just looking at this equation. This is actually the first one. If m plus 2 is 7, and then that means that the 77 minus u guy would be 4 times 11, which is 44. Right? So these ones are, we can't, there's nothing. So that means that 77 minus u is 44. So that means that u would be 33. So you see how you calculate 33? And then similarly for all these other ones, I'll just do a couple more. If m plus 2 is 11, then that means the 77 minus u would be 4 times 7, which is 28. And then therefore u would be 77 minus 28, which I believe is, what is it, 49? Yeah. And then similarly, you can calculate all the other ones. This is 22 and 55. This is 14 and 63. And this is 11 and 66. This is 7 and 70. This is 4 and 73. This is 2 and 75. And this is 1 and 76. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And is that what the question's asking? Determine all possible positive integer values of u. Okay, and I think I did that. 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. Determine all prime numbers p for which there are exactly 17 positive integer values of u for polar rectangles with n equal to 10 and r equal to u over p squared. N is 10 in this question, and r is u over p squared, and p is a prime number. So here we go. So just like before, our ratio of shaded to unshaded was m minus 2 over n minus 2 over m times n minus m minus 2 times n minus 2. And that ratio, if I simplify all this using n equals 10, it will become 8m minus 2, and then 10m minus 8m plus 16, and then this looks like 8m minus 2, and the denominator is 2m plus 16. And continuing this, if we take out a 4, or let's see here, we divide top and bottom by 2, then we can get 4m minus 2 on the top, and on the bottom it will be m plus 8. Okay, so but that's about as far as we can get. And we are told that this ratio is equal to u over p squared. All right, and that's pretty much how far we get based on what they gave us in the question. And then we have to figure out values of p, for which there's exactly 17 values of u. Okay, so we'll get to that later, but first let's try to simplify this to make it digestible. Okay, so we have to rearrange this, and this thing is r, correct? So I'm just going to put r. So r is equal to 4m minus 2 over m plus 8, like that. Okay, so let me just bring the 4 down first, m minus 2, m plus 8, and then let's see what I can do from here. I'm going to, this m minus 2 is the same as m plus 10, m plus 8 minus 10. Yeah, I'm just going to rearrange it because I want to get part of the numerator to look like the denominator. And when I do that and I break it up, it'll be m plus 8 over m plus 8, and then minus 10 over m plus 8, like that. And then this r over 4 will be 1 minus 10 over m plus 8, like that. Okay, that's pretty decent. Now I can bring this over to the other side, 10 over m plus 8, like that. And then it'll be 1 minus r over 4. Okay, now at this point, I'll make this substitution. So this is going to be 10 over m plus 8 is equal to 1 minus, it'll be u over p squared, and then I got to stick that 4 out there, correct? Yeah. Okay, then what else now? I guess I could add this fraction, 4p squared minus u over 4p squared is 10 over m plus 8. And then now I can just cross multiply, and I get 40p squared is equal to m plus 8 times 4p squared minus u. Okay, so I got it down to this guy right here. Okay, so now let's go back and remind ourselves, what is our goal? Our goal is to find values of p, remembering that p is a prime, for which there are exactly 17 values for u. So sounds like a weird kind of goal, but that's our goal, and this is the simplified expression. Now what I'm going to do is I'm going to walk you through the correct solution, and I'll let you guys do the other ones. So what you do is you experiment. So I'll make a little table and I'll show you how it's done, and then you guys can do, because I'm not going to do everything for you. I can't hold your hand through the entire question. So you make the little table. So we got p, 40p squared, and then we have divisors of 40p squared. And then we have our m plus 8, and then our 4p squared minus u. And then we have the number of values for u. Okay? So here we go. And then we got to test different prime numbers. So what's the first prime number? It's 2. and then the next prime number is 3, then the next prime number is 5, then the next prime number is 7, and then all the other prime numbers that are greater than or equal to 11. Now, if you say, well, how can I possibly test every single prime number? You don't. You'll see that for this scenario, every prime number that's greater than or equal to 11, the scenario will be exactly the same. That this will be, it will not be equal to 17. So let me show you how it's done. Okay, so I'm going to show you how it's done for the correct answer. And the correct answer is 7. Now, when P is 7, let's just see if we can squeeze in the... When P is equal to 7, we have basically this equation becomes, let's just write it in red here, it becomes 40 times 7 squared. Okay? Now, 40 times 7 squared in terms of its prime factorization is 2 to the power of 3 times 5 to the power of 1 times 7 to the power of 2. Now, you guys remember that if we break it up into prime factors, you can figure out the number of divisors. You take the first exponent, which in this case is 3, add 1. Then you take the second exponent, which in this case is 1, add 1. And you take the other exponent, which in this case is 2, and add 1. And you multiply. So there's 4 times 2, which is 8, times 3, which is 24. So that means there's 24 divisors of P squared. You got it? So that's how you do that really quickly. Now, I'm going to list them all. I'm going to list the divisors. Let's just do it over here. Make the list here. List of divisors. Now, there's 24, so let's see if I can get them all here. 1, 2, 4, 5, 7, 8, 10, 14, 20, 28, 35, 40, and then 49, 56, 70, 98, 140, 196, 98, 140, 196, 245, 280, 392, 490, 980, and 1960. Right? Okay, so those are the 24 divisors. Okay, so now you have to remember that we have to now look at this guy and this guy, right? So, and also keep in mind that m was greater than or equal to 3. So if m is greater than or equal to 3, then this m plus 8 would be greater than or equal to 11, right? Just based on the parameter that they give us very early in the question. So if m plus 8 is greater than 11, we can immediately eliminate some of these guys. We can get rid of, I think, these ones. Because m cannot be, m plus 8 has to be greater than or equal to 11. Those are obviously not. So that's how many? 1, 2, 3, 4, 5, 6, 7. So 7 of those are invalid. So of the 24 in the list, I have to get rid of those 7. And that leaves me with 17. So that means there's 17 possible choices for m plus 8. Correct? And for each possible choice for m plus 8, there will be something for this 4p squared minus u. So I'll just write that out. So basically exactly what I said. For there's 17 possible choices for m plus 8, and therefore 17 choices for 4p minus u. Because whatever you put in this equation for this guy, right here, you will be able to put something for that guy. So 17 choices for this, 17 choices for this. And then 14 p squared minus u, when p is equal to 7, is basically 196 minus u. And 196 minus u will have 17 choices. 17 choices. And for each of those, you will get one value for u. You will get one value for u for a total of 17 values for u. And that happens when p is equal to 7. So for all of these other guys, p equals 2, p equals 3, p equals 5, and then all the other ones, you'll see that if you go through the same process, that it will render a number different than 17. I think I had put that earlier. It won't be 17. I think this one renders 12. This one renders 24. I actually don't remember, but this one, well, basically they don't render 17. This one renders 17. So that's basically how you would approach this question.